Hello everyone, let's discuss integration along a path. First, let's define integration along a path. Let gamma go from a to b to the complex numbers be a path, and let a to an equal b be such that gamma restricted to the interval ak to ak plus 1 is smooth for k between 0 and n-1. Let f be a function from gamma star to the complex numbers and let it be continuous, so that the composition f circ gamma times gamma dash from ab to the complex numbers is a piecewise continuous function and hence integrable. Then we define the integral over gamma of f of z dz to be the integral from a to b of f of gamma of t times gamma dash of t dt. The motivation for this definition is the formal substitution of gamma of t for z. Now, let's state some properties for this form of integration. First, suppose that gamma is a function from a to b to the complex numbers and is a path, and that f and g are functions from gamma star to the complex numbers and are continuous, and that lambda and mu are complex numbers. First, we have the linearity property that the integral over gamma of lambda f plus mu g of z dz is equal to lambda times the integral over gamma of f of z dz plus mu times the integral of gamma of g of z dz. Also, we have the inversion property that the integral over the inverse of gamma minus gamma of f of z dz is equal to minus the integral over gamma of f of z dz. We also have the additive property, which says that if a is less than c which is less than b, put gamma 1 equal to the restriction of gamma over ac and gamma 2 the restriction of gamma over cb, then the integral over gamma of f of z dz is equal to the integral over gamma 1 of f of z dz plus the integral over gamma 2 of f of z dz. Now let's discuss the reparameterization property by supposing that phi goes from a tilde to b tilde to a to b and is a continuously differentiable bijection, and put gamma tilde equal to the composition of gamma with phi. Then the integral over gamma tilde of f of z dz is equal to the integral over gamma of f of z dz. Next, let's discuss the fundamental estimate. Suppose that gamma goes from the integral ab to the complex numbers is a path, and that f is a function from gamma star to the complex numbers and is continuous. Then the modulus of the integral over gamma of f of z dz is less than or equal to the integral of a to b of the modulus of f of gamma of t times modulus of gamma dash of t dt. A corollary of this is that if m is equal to the supremum over all z in gamma star of the modulus of f of z, and L is equal to the integral from a to b of the modulus of gamma dash of t dt, which is the length of gamma, then the modulus of the integral over gamma of f of z dz is less than or equal to m times L. However, there is a warning associated with this. When using the fundamental estimate, do not make the mistake of writing that the integral over gamma of f of z dz is less than or equal to the integral over gamma of the modulus of f of z dz, as this may or may not be false. Then, let's talk about the fundamental theorem of calculus. Suppose that gamma goes from the interval ab to the complex numbers is a path, and that capital F is a holomorphic function on an open set containing gamma star, and that the derivative of capital F of z is continuous at each point in gamma star. Then the integral over gamma of f dash of z dz is equal to f of gamma of b minus f of gamma of a. In particular, when gamma is closed, then the integral over gamma of f dash of z is equal to 0. If we are given a function f which is continuous on the image of some closed path gamma, and that the integral over gamma of f of z dz does not equal 0, then, by the fundamental theorem of calculus, there can be no holomorphic function f on gamma star such that f dash is equal to f. Following on, let's mention the relationship between uniform convergence and integration along a path. Let gamma go from the interval AB to the complex numbers be a path, and for n going from 1 to etc, let f sub n be a function from gamma star to the complex numbers, which is continuous. Suppose that f sub n converge uniformly to f, a function from gamma star to the complex numbers, on gamma star. Then the limit as n approaches infinity of the integral over gamma of f sub n of dz is equal to the integral over gamma of f of z dz. Now let's combine this with the Weierstrass M test. Suppose that gamma is a path and that u0, u1, etc. are continuous functions on gamma star. Put f sub n of z equal to the sum from k equals 0 to n of u sub k of z, so that f sub n is a continuous function on gamma star, and by additivity the integral over gamma of f sub n of z dz is equal to the sum of k equals 0 to n of the integral of gamma of u sub k of z dz. Suppose that f from gamma star to the complex numbers is such that f sub n of z converges to f of z for all z in gamma star. Suppose further that there exists a real constant m sub k such that the modulus of u sub k of z is less than m sub k for all z in gamma star, and k going from 0, 1, 2, etc, and that the sum of m sub k converges. Then, by the Weierstrass M test, f sub n converges uniformly to f on gamma star, so the integral over gamma of f of z dz is equal to the limit as n approaches infinity of the integral of gamma of f of z dz, which is equal to the limit as n approaches infinity of the sum as k goes from 0 to n of the integral over gamma of u sub k of z dz, which is equal to the sum as k goes from 0 to infinity of the integral over gamma of u sub k of z dz. In other words, where we can apply the Weierstrass M test, we can exchange the order of integrals and infinite sums, i.e. the integral over gamma of the sum from k equals 0 to infinity of u sub k of z dz is equal to the sum from k equals 0 to infinity of the integral over gamma of u sub k dz. And, as ever, thank you for watching.